Hello, everyone. My name is Jeffrey Johnson, and today I'm here to talk about the effect of AI powered tutoring systems on mathematical achievement in secondary schools. I chose this topic because there was a lot of information out there on this topic, and I felt like it gave me a great deal of research and background information that would help provide context into this topic and why I felt like it was a good topic to continue to divulge into. And seeing that AI has been, obviously moving in a different direction in terms of the school systems, I felt like this was, a very good, important topic to discuss. So, obviously, it's no news that artificial intelligence is taking over in every sector of education. And it introduced many different opportunities for teachers and students in academic success. One of the highlights of it is just the development of tutoring applications and kids being able to get different types of tutoring that will be able to obviously help them in terms of staying focused. And we all know, obviously, with mathematics and Excel, that it is a hard subject for different students to understand, and many students obviously have trouble, in math. So being with the AI tutoring system, the challenges of kids being able to get the help that they need, they can finally improve the math scores overall. Just with going into the overview of it, so we talked about a growing body of research that has been investigated in the role of AI tutoring enhancing student learning outcomes. The findings show that well-engineered AI tutors produce educational lifts in students' achievement. In a 2025 randomized crossover study at Harvard, undergraduates who learned physics through an AI tutor scored twice as high on post-tests as peers in active learning classrooms while using less time on task. The 2024 Standard University found students using human math tutors with an AI co-pilot raised their master by 4 points. A systematic review of experiments across STEM domains report 15 and 35% average scores for students in AI powered versus traditional conditions. I thought that was very big because when you look at the landscape of it, and that obviously provided a great deal of background with students scoring higher by 4 points. When you talk about having an AI co-pilot raised tutoring system versus the classroom tutoring system, I feel like it just obviously gets the kids to focus more, and it may be able to get the information across to them in a way that they're able to understand it. So collectively, the evidence indicates AI tutor systems can enhance learning outcomes, but the effectiveness hinges on deliberate instructional design and its and integration within human instructor rather than standalone deployment, which again goes into a little bit from what I was obviously stating earlier. When it comes to, I feel like the tutoring process and learning from someone versus learning from AI, the information can be brought to the students differently than being taught to someone within a classroom setting or face to face. So I feel like that definitely was a key point in the research, with the findings that helped bring this along. So some of the research questions that I looked at was, how do students perceive the effect of AI powered tutoring systems on their understanding, achievement, and mathematics? How do teachers and students describe the role of AI tutoring system in supporting or hindering master of mathematic concept? What classroom dynamics and student behavior emerge when students engage with AI powered tutoring system, and how students perceive the support provided? And then the last question was, what factors influence whether AI powered tutoring system positively impact student learning outcomes in high school mathematics? So just starting with the first one, how students perceive the effect of AI powered tutoring systems on their understanding and achievement in mathematics. I felt like with using that type of question right there, that gave the students, and those questions were also questions that were, obviously asked in a research study done for kids to be able to ask in high school the different effects of AI and how it was coming across to them and being taught to them. So this is something that they were able to fill out and answer and then provide feedback on in terms of how, with the AI focus, how it was helping them and the factors that they needed in terms of mathematics. So we did a study. The study involved 24 high school students and 4 mathematics teachers from 2 public high schools in the Midwest District. 2 schools had integrated an AI-powered tutoring system for the first time in the STEM object. Participants were selected using a purpose sampling method to involve individuals who can provide detailed accounts of their experience with AI tutoring system in that semester. Students will be reunited through teacher referrals and classroom announcement. Teacher participant was through innovation directly by the school administrator. Consent forms were provided to both the students and parents, guardians, in compliance with ethical research protocols. After parental consent forms were emailed and follow-up calls were made, 24 of 28 students agreed and 4 declined. 2 of the students declined because of sports schedule, while the other 2, the parents were worried about being audio recorded. A total of 6 teachers who had used AI tutoring daily for at least 2 semesters were invited, and only 4 accepted. The remaining 2 felt like they could not spare prep periods for interviews and other observations. So obviously with something like that, in terms of getting a good amount of teachers and students, I felt like that was a good amount of teachers and students to be able to use in terms of collecting data. The way that the data was collected was, the study used 3 different types of data collection method to capture the different angles on how students and teachers make sense of AI-powered math tutoring. The first was conducting a semi-structured interview of 20 minutes with all participants during the prep period. Each participant was asked a simple open-ended question. Tell me about the moment a tutor really helped or confused you. The research proceeded to do 2 lesson length observations per participant in a natural classroom setting. The observation entailed noting who stayed on task, how quickly students called their teachers after a hint. Lastly, the archive record of students' grades and teachers' notes of the lesson of the previous semester and under study was accessed with consent. These logs provided an objective trajectory of each student's skill mastery, time on task in minutes, and grade, providing a measurable factual bias for analysis. So I felt like that was a good way to collect the data in terms of, obviously the different questions. I like the open-ended question. I thought was great that I came up with, which was tell me about the time a tutor had really helped or confused you, because there are so many different times when you're struggling in a subject and you go to get help from a tutor, or whether that be free or your parents are paying for a tutor, and you feel like that you're not understanding where the tutor is coming from, or they're not explaining it in a way that helps you to understand the context in itself. So you kind of struggle a little bit and feeling like, well, hey, is this tutor actually working? Do they know what it is that they're talking about? Should I be using a different tutor? So then it obviously starts to bring into a question whether you can actually learn or pick up on this subject. So obviously, this talks again a little bit about the related research. The studies show how AI improved learning outcomes. Obviously, talked about the Harvard AI tutor group doubled with post-test scores. AI supporting tutor increases master by 4 points, and then also the STEM quiz experience going up between 15 and 35% average gains. So obviously, what I just talked about a minute ago, which was those research questions, and these were the research questions that, again, that were asked for the teachers as well as the students, and how we went about collecting the data in terms of their answers. So obviously, this goes into how many participants, which was again 24 high school students, 4 math teachers. The purpose of sampling across 2 Midwestern high schools, 86% of the student participation, limited by availability. Obviously, conducted semi-structured interviews, 20 minutes each, 2 classroom observations per participant, archive logs, grades, and different data, and time on task to be able to get the full collection of data we needed to, kind of see whether the AI approach in tutoring for mathematics was going in the right direction, and whether kids' grades were getting better or they were, getting worse. So the data coding approach codes for interviews, observations, and archival logs, grouped into themes such as understanding, confidence, frustration, etc. Excel and Word was used for coding and organization. So there were different types of code words. So it could be in an interview perceived as understanding, I get it now, confidence increased, or frustration. So open coding of all qualitative data, 6 category coding scheme created after saturation. Peer coded reliability at 86% agreement. The data analysis began with the importance of interview transcripts, observation sheets, and archive log, and the qualitative data analysis too. Open coding was first applied by highlighting every sentence related to learning, help, and feelings. After 24 interviews, and similar letters were grouped into 6 categories, including skill growth. So with the overview, the findings show 3 clear relationships emerging from the data. First relationship is students who entered with weak basic skills only raised their mastery scores when the teacher followed AI drills with short mini lessons. The lessons linked micro steps to bigger math ideas. For without these bridges, masters stall. Second, high achieving students show little to low mastery if they relied on rapid hints. Their progress improved only after the teacher supplied non-routine problems that forced deeper reasoning. Third, full dependence on AI, where students relied on hints more than 3 times in the span of 30 seconds, resulted in a quiz failure and stalled learning. The data also showed the student praised for instant judgment-free feedback. Observation shows 78% on task time, and the archive log recorded an average of 2.8 new topics per week. Additionally, when grades were recorded compared to the previous semester when AI tutoring was not employed in the current semester, 19 of the 24 students showed improvement in grades in mathematics. So just going through in terms of the summary, uh, I felt like the AI tutor increased confidence and mastery for many students. That it was even for the teachers, the role shifted towards connecting concepts and deeper reasoning, so that the students could understand. Over reliance caused shallow learning. Teacher interventions also helped with that. Short study duration, no control group, the lack of long-term retention data, hybrid AI teacher recommended, equity concerns for Wi-Fi and device access. Now, obviously, when it comes to the AI in itself, there's always going to be ups and downs with it in terms of obviously the kids making sure that when they are or they do need access to the AI, that you obviously have Wi-Fi and you have a device that's capable of being able to for the kids to be able to use for to get the help that they need. These are some of the references from a few of the places where I did get the data that I had collected. So again, I do want to thank you guys for tuning in to my presentation today. Thank you.